is why are some functions not integrable, and how can one determine whether the given function is integrable or not?
Okay, that's a very good question. So let's take the function sine, oh wait a darn second. So let's take the function cosine x over x as a little bit of an example. So sine x over x, its younger brother, is very well behaved. It is equal to 1 right at its peak over here, then it slowly decreases over time. And of course it has a defined integral. But then, what about cosine x over x? Well, okay, as it approaches 0, this approaches 1, and this approaches, well, 0. Meaning, this is going to approach infinity. So essentially, at some point, we kind of have infinite area that is occurring right over here. So, something like this, perhaps. And this is just completely non-integrable. I mean, how do you find the infinite area that goes on over here? So sine x over x is integrable, but cosine x over x is completely non-integrable because of what happens over here. And in the same vein, we also have sine of 1 over x, which goes absolutely crazy when it's near 0. So this is what we call the topologist curve, and essentially it looks like this. So it calms down when it's not near 0, but then it speeds up in frequency until eventually the frequency is absolutely huge. And then as you get away from the origin, it slows down again. So this is what sine 1 over x looks like. And as it gets infinitely, as its derivative goes to infinity, right around here, this is pretty much impossible to integrate, as you can see. I mean, how do you even integrate this? Because all these little infinite humps, they themselves, you have to add them all together, and it's just an absolute mess. So these are two functions that I would say are completely non-integrable. So if anyone knows of anything else, I'd be happy to show that. But yeah, so that's yes, 1 over x is indeed integrable. Of course, not from negative infinity to infinity, but it is integrable on the positive because turns out that this area over here is finite, kind of like the area of a square minus a quarter circle. Turns out that this area is of course finite, and the integral of it is ln over x.